I'm going to talk through 6-4. 6-4 is looking at inequalities in one triangle. So here I made a triangle. Okay. It's triangle ABC. And you can see that in this case, angle B is the largest angle. And then if you look at the sides, the largest side is CA. The smallest angle is angle C, and the smallest side is happening across from that. If I drag to change this so it's not the same angles, now I made angle C the largest angle. Angle C is the largest angle. Now compare the three sides. Where's the largest side? Across from it. Where's the smallest angle? Right down here at angle A. And where's the smallest side? Across from it. Okay, so that's one of the main ideas we're looking at, which kind of makes sense because when you think of an angle as kind of measuring the space between two rays, the larger the angle, the farther it's going to be to go from one side to the other. So for our first part here, if one side of a triangle is longer than a second side, then the angle opposite the first side. Okay, well this would be just what we were looking at, where we had a triangle. Okay. And so if one side of a triangle is longer than the second, then the angle opposite the first side is larger than this second side, the angle opposite the second side. Okay. If I try and do this, what that's kind of saying is if this is a really large angle and this angle is smaller, and we're talking about the angles and comparing these two angles, that the side opposite the large angle is going to be larger than the side opposite the smaller angle. Or I said that opposite. Okay, this is the same thing. So basically you're looking at the angles and the sides. If I know this side is larger than this side, then I know the angle opposite it is larger than the angle opposite the smaller side. As we go into this here, the perpendicular segment from a point to a line is the shortest segment from the point to the line. So let's think about that. Let's draw, here's a line, here's a point. Okay, so there's the point. And it's saying the shortest distance. I think some of you can just logically figure that out. But let's look at it in terms of the triangles, which is why this is a corollary. Okay, if I draw a perpendicular from here to here. Now let's say someone rejects that and says, that's not the shortest distance. I could draw a line from here to here. And why can't that be the distance from this black point to this black line? Well, think about it in terms of a triangle. Look at the triangle here. Here's the 90-degree angle. So what can any angle in this triangle, can any of these other angles be more than 90? No, we've talked about this before. So that means the angle opposite the 90 must be the largest side. Now, notice that it's not comparing the blue side and the black side. We're not saying I can compare these two. All they're saying is if you look at the two lines coming from this point right here, the shorter one is going to be the perpendicular than any red line you might draw in. So that's what that's saying. The same idea here with a perpendicular segment from a point to a plane is the shortest segment from the point to the plane. Okay? So again, they're not comparing the blue and black sides of the triangle because I don't know about those. I'm not quite sure the blue is longer than the black or anything like that. But when you look at the distance from the point to the line, you have an option of a perpendicular or any other one. But once you draw in any other line, it will be longer because it'll form a right triangle, and the side opposite the right angle is always going to be the greater side. Okay, for this, the sum of any two lengths of a triangle is greater than the length of the third side. This is kind of that idea. But let's also think about it kind of logically. We'll start here with this one. Is it possible for a triangle to have sides with lengths indicated? Well, if I take 6 plus 8, is that greater than 10? Yes. So this is hard to do. Okay. So 6 plus 8 is greater than 10. You can write these down. 8 plus 10, is that greater than 6? Yep. Is 6 plus 10 greater than 8? Yep. So for this one, is it possible to have a triangle that does this? Yes. For the next one, the problem is going to come up with 3 and 4 and 8. 3 plus 4 is not greater than 8. So let's look at that for a second here. Let's say this is my side of 8. Okay, now you want to take a side of 3, and a side of 4, and you'll see even if you laid them flat on the side of 8, you took those two pieces and laid them flat, they're still not going to reach all the way across to make a triangle. So that's why this isn't working. Okay, so you need the two sides to be greater than the third side. Now, some of you might say, well, why can't it be equal? Well, let's look at that situation. Let's say we had a side of 8 again, and we had a side of 3 and a side of 5. Well, if I took my side of 8, I laid down my 3, and I laid down a 5, those are going to be lying flat on top of each other. There's going to be no way to kind of pop up to make a triangle. It's just one line laying on top of another line. So that is that. Even if it's 0.1 greater, the sum is 0.1 greater than the third side, that'll at least give me that little bit of lift to get the triangle. So this one is, let me try this instead. This one would be no. Okay, you can push pause and try the rest of these. Okay, this one is a yes. This one is a no, and that's because they're equal. We talked about that. And this one is a yes. Okay, find the largest and smallest angle. Well, here you'll start with what is the largest side. Here it is. So the side across from it, or the angle across from it, must be the largest angle. Here's my smallest side. So this must be across from it, my smallest angle. Okay. So my largest angle equals I, and my smallest angle equals J. You guys could use your symbols. It's a little hard for me to type those on here. Now over here in the next example, we were given 2 of the angles, so you're going to need to figure out that third angle just to double check that that's not going to affect you too much. So that third angle is 29. So this is a 29. Okay, so to find the smallest side, here's my smallest angle, I'll go across. Here's my largest, I'll go across. Okay. So longest equals, you guys would use the segment notation, RT. Smallest equals RS. Okay, this is kind of going over that idea I talked about before. Triangle ABC is a right triangle with a measure of angle C equals 90. Because we know the sum of the angles of a triangle is 180, there can only be one 90-degree angle. So, let me go back to the pen. We know angle C is going to be greater than angle A. It has to be the biggest one. Angle C is going to be equal to angle A plus B, okay, because they have to equal 180 together. Oops, I made that wrong. Okay, so this is C, A, and B, where I made angle C the 90-degree angle. So AC and AB, okay, I'm sorry, AC to AB over here. Again, I can't compare AC and BC because I'm not quite sure what those angles could be. They could be 45-45, but they could be 20-70. They could be a lot. But I definitely know the side across from the 90 is the greatest side because it's across from the greatest angle. So for angle, so AB is going to be greater. Over here, we're again talking about the length of the third side must be greater than but less than. Remember that the two sides together have to be greater than the third side. So in that, even that idea here, if I have a 10, or I'm sorry, a 12, I'll take the larger one. If I lay down a 10, this part over here, it can't, even to be 2 would just make it equal to each other. So I have to make sure this red part is greater than 2. Okay, but we also have to remember that when I add the 10 and the 12 together, that my third side cannot be, my third side cannot be more than that. Okay, so 10 plus 22, so it's going to have to be less than 22. For 25, you can try the rest of them and then come back. All right, for this one, you need to be greater than 0. And you're going to need to be less than 50, which is the sum of 25 and 25. Over here, you're going to need to be greater than 0. And you're going to need to be less than 10x. Over here, you're going to need to be greater than 2, okay, because if the other one was y plus 2, remember it would just kind of lay on top. And I'm going to need to be less than 2y plus, sorry, that's a 2. Okay, so for homework, you're going to work on page 222. One through 17. Okay, any questions, come see me. Thanks.